Hello guys, welcome to the channel. We are learning object-oriented programming, and in this video we are going to talk about property decorator. In the previous video, we have looked into the details of different types of methods like class methods and instance methods, static methods, and property decorator is kind of an extension of that idea. So we will try to understand the different aspects of the property decorator and where it is used using a lot of relevant examples. At the same time, I've also introduced some other concepts like backward compatibility and lazy computation and caching. All of these terms are also going to help your understanding of general software development cycle. And if you're new to the channel, this video is a part of my hands on Python for beginners playlist. The link will be in the description below. With that being said, let us now quickly jump into the video. So let us get started with property decorator in Python or a property wrapper in Python. Before we do that, I just want to quickly do a recap of what we have discussed in the last couple of videos. So we have basically emphasized on the different types of methods like class methods, static methods, instance methods, or regular methods, right? So property decorator is kind of an extension of the idea. It is basically a bridge between attributes and methods. It is going to allow us to use a method as an attribute. So why would we want to do that and what are the possible use cases is something that we are going to explore in this video. So I have some notes for you here. It says the property decorator is a built-in decorator in Python. Again, decorator is something that I have not discussed up till now. We'll do that a little bit later. I'll make a detailed video on it. But for now, you can just keep in mind that decorator or a wrapper is basically used to modify the functionality of a function. It's a built-in decorator in Python that is going to help you, that allows you to define methods that can be accessed like attributes. This is the key thing that you have to remember. Methods that can be accessed like attributes, which will enable controlled access to instance variables. Now what does this mean? Something we will see. Okay, it's a part of Python's property mechanism, which helps in implementing getters, setters, and deleters. Okay, getters basically means when we are accessing an instance variable. So you up till now we have been doing Ramesh dot name, Ramesh dot full name, like that. Okay, so that is basically getters, and setters is when we set an instance variable. So we have learned how to do that using the in the init method, and we have also seen that we can do it directly, like we have done Ramesh dot name is equal to something. Okay, so we have been able to get and set some values to instance variables. Now there are a lot of situations where getting or setting values this way might not be the optimal way of doing it. Suppose we want to have some security, or we don't want anyone tinkering with the different variables which is there inside the class, or how to delete a certain instance variable, right? So these are the things. This is a high level overview of where property decorator might come in handy. I've also listed down some use cases. So there are a lot of use cases, but I've bucketed them into these broad 6 buckets. The first is readability and encapsulation, validation, computation of attributes, backward compatibility, lazy computation, and caching. Okay, so we will see all of this one by one using examples. But first, I want to just tell you what is property decorator using the syntax, and then we'll discuss the use cases. So let us quickly get started. In order to understand the need for the property decorator, let me go back to an example that we were doing, I think, in the second video of the series, where we created this class called employee, and we added an init method here, and we took name, department, date of birth, and we tried to find out the email, or we tried to create an email for that employee using the name. Okay, and we created a method here that was returning the email, and we assigned that as an attribute here, because we didn't want to call the get email function. We wanted to see email as an attribute, so we created one attribute here using this method. Now this looks fine, and I did show this way when we were discussing about oops in the beginning. But actually, if you observe, there is a very big problem in the way this code has been written. And let me take this to our notebook, new notebook here, and let us try to understand what is wrong with this and why we should not actually be doing this. Let me copy a couple of employees as well. Now you see what's the problem here. The problem is that we are assigning name, department, and date of birth at the time of creating the instance Rohan. Okay, and the email is calculated based on the name, which is whatever is the name lower at the rate gmail.com. Okay, now what happens if we decide to change the name later? Suppose Rohan wants to change his name to Mohan. If we do rohan.name, it will come as Mohan, department and DOB is fine. But if we do email, it will it will show Rohan, because email has already been calculated and it has been set. It is not being dynamically calculated, and it is not going to reflect all the changes that are happening in name. Let me show you using an example. So I've created this Rohan class. Let me zoom out a little. Okay, I'm going to come here and I'm going to say rohan.name and rohan.email. Okay, so it says rohan and rohan@gmail.com. Now I want to change name of Rohan. Okay, let me make it Mohan. Now, this itself is a problem because we are directly assigning a name or we are updating the name of an instance. There has to be some kind of validation. There should be some checks in place. We should not be just allowed to add any value or update any instance just like this. So this itself is a problem, but we will try to solve this problem later. For now, we are talking about dynamic calculation of email. So if I update Rohan's name to Mohan, and if I access this line of code again, okay, I'm going to expect rohan.name to become Mohan, but what do you think will happen to rohan.email? Will it become mohan@gmail.com? No, it is still rohan@gmail.com. Email was once calculated when the name was Rohan, and after that it is not being calculated again. It is stored here. Okay, it is not taking the dynamic changes of name. So this is going to be a very big problem, and that's why we should not be following this method. We should not actually be doing this. Now, by the way, you might also argue that what is the need of having this email here? Why not simply have get email? Okay, so if we just have get email, when we have rohan.name, of course, email is not going to work here. We will need to add get email here, and it is going to give me rohan@gmail.com. And once we update the name to Mohan, and instead of rohan.email, if we do rohan.getEmail, it is being updated mohan@gmail.com. So this method is actually taking in the changes. But the problem here is about readability and syntax. So here email is actually supposed to be an attribute, but forcefully we are converting it to a method. So we don't have a get underscore name. We don't have a get underscore department or a get underscore dob, but we have a get underscore email. So this kind of breaks the convention, and it is not very readable, and it is not the syntactic sugar that one might expect from a very well written code. So you might be wondering what might be the solution to this problem. The solution to this problem is exactly the topic we are discussing, which is the property decorator. So I'm going to remove this method, okay, and I'm going to remove this attribute also from here, and I'm going to create a method called email, okay, and I'm going to pass self to this, and I'm going to return the email here like this, okay, and I'm going to convert this method to a special method using this property decorator. The moment I add this property decorator, this becomes like an attribute. Now email can be accessed like an attribute. So I can come back here, I can create this, okay, and instead of get email, again I can come back and use email, not with this brackets, because this email is a method, but because of the property decorator, this becomes like a attribute. So I can come here and see rohan.name, rohan.email is fine. Now I'm updating name of Rohan, and again I'm coming here and writing email, remove the parenthesis, and you see it is being updated dynamically. So this is the need and this is the requirement for property decorator when we want a method to be used as an attribute. So we discussed one possible use case of property decorator when we want that attribute to have a dynamic value, or we want that attribute's value to be dynamically calculated, especially when it depends on some other variable or some other instance variable. Okay, and at the same time I don't want to use it as a method, because if we are using it as a method, we will have to use get email or find email or calculate email, something like that, and that actually is not very readable, and it is not a very good syntax that you might want your class to have. So in such a situation where we want a dynamically changing attribute, a property decorator comes in very handy. So this property decorator, when we write it like this is also called as a getter. So this is also a getter. So this is going to help us get a value of an attribute. Now here we can also have some kind of any logic you want. It is just returning here self.email.com, but if you want, you can also possibly add some logic here, which we will see in a while. So here we talked about the property decorator and the getter nature of it, which is to get the value of an instance variable. Here we used email to get the value of an email. But what about when we want to set the value for an instance variable? For example, I just told you a moment back that here we are trying to set the name for Rohan as Mohan, and actually there is no validation or there is no check that has been put into place so that an invalid name or maybe a junk name is not entered as a name for Rohan. So there should be some check here, or in fact, what happens when we try to set the email for someone? So email here by design is calculated dynamically using the name. Or what happens when we try to, or what happens when someone tries to set the email? to some absurd value. So this property decorator is actually going to prevent it, and it is going to give us a little bit of control as to how the value is going to be set. So let me try to override the email here, and let me say rohan dot email is equal to, let me put some absurd value and see what happens. Okay, you see it gives me an error. It is not assigning the value for the email, and it says attribute error, the property email of an employee object has no setter. So what happened here is, when I created this email method and I made it as a property, this email was acting as an attribute, and this is how we are going to access the value of an email. But this is not going to allow us to set the value of an email. Okay, so when someone tries to set the value of an email, it is going to give an error, which is okay, because the way we have designed it, we want the email to be calculated from the name, and if someone wants to modify their email, they can just change the name. But there can be a way where we can allow someone to set the email also. So here what I want to do is, when someone tries to set the value of an email, I want to give a message to the user that he's not allowed to set the email instead of this red box here. Or I can also do anything else. Maybe I can raise some specific error, or I can show any message to the user instead of this. So in order to control what happens when someone tries to set the value of an email, I'm again going to write a method which will be email, and I'm going to pass self to it. And this time again I want to add a decorator called name, sorry, not name, email, whatever is the name of the attribute that we have created using the method, property method. Okay, email dot setter. Okay, so this method is now going to get executed whenever someone is trying to set the value of an email. So as of now it is giving me an error because setter has not been defined. So I am defining a setter here, and this is exactly the way we have to put it. We have to use the name of the attribute and dot setter. So this is predefined, and I'm going to come here and I'm just going to print, you are not allowed to set or update the email. Email is automatically calculated using the name. Here I also need to enter the value that the user is trying to set to email. So this method has to accept that. And if I run this, and now if I come and create the employees, everything is fine. Now in this line of code, I'm trying to set the value of email to Rohan, to Apple. Now if I run this, you see what happens. It says you are not allowed to update the email. Email is automatically calculated using the name. So instead of getting that ugly red box error, I'm giving a meaningful response to the user who's trying to set the value. So the summary of the story is that getter and setter is allowing us a control, a custom control on what happens when we are trying to fetch the value of an attribute, what happens when we are trying to set the value of an attribute. Similarly, there is also an idea of deleting the email. So we can also use deleter, so which is not used much often, but just because we are on the subject, I'll just quickly show you before moving on to another example. So I can come here and I can write email again, and I'll take self. Okay, and I'll just write print. Okay, deleting the email. Okay, so I don't want to actually delete the email, but here I will come here. I'm just showing you what we can do. So I'll come here and I will write email dot deleter. Okay, so again I'll create the instances. Fine, everything is fine. I'm getting this message, and if I do rohan dot email, I'm getting mohan at the rate gmail.com, because that is the name we have set for Rohan. Fine. And if I delete this, okay, if I come here and if I delete this, you see it says deleting the email. So when we try to delete an instance variable, whatever we have written in this logic, it gets executed. So here you might be tempted to think that we are not actually deleting anything in this deleter function or in this deleter property, and we are just adding this print statement. So the idea here is to show you that the getters and the setters method and the deleter methods here actually are allowing us to add some custom logic. But the way we have written this specific example, where we are calculating email on the go, so here the deleter is not going to make sense. We actually cannot delete the email here, because the email actually is not stored anywhere. Whenever we need email, we are actually calculating the email. So even if you delete, even if you run a statement here like self dot email is equal to none, first of all it is not going to run, because this itself is a setter statement, and in the setter statement we are just printing and we are not doing anything. But even if we did not have this restriction in the setter, even if we did this and somehow if we were able to set the email as none, still it will not make any difference, because the next time user calls email, again we are going to calculate the email and we are going to show to the user. So unless the name is also deleted along with email, this deleter is not going to work. But that is only because of the way we have written this example. But in other examples, you can actually use the deleter. So I'll show you a way in which we can do that. So I'm going to take the same example and I'm going to add few more functionalities and show you few more things that we can do using the property decorator, especially data validation. So when I was doing this example here, I told you that we are assigning this name instance variable to Rohan and we are assigning it to Mohan, but actually there is no restriction as to what we can assign as a name. So we can actually put any absurd value or any junk value, maybe 1 2 3 4 5, or some special characters which is not a valid name, and there is nothing in the code that is prohibiting us from doing that. So I'm going to add some data validation, and that will also give you an idea of one other use case for this property method, which is putting some checks while doing a setter. So that we have already seen here. When we did this setter, we put some custom logic here, but we made this print statement. But other than this print statement, we can also add some logic. So let me take the same example and come down, and I want to show you more examples. And all of this actually comes under encapsulation because we are hiding some internal logic from the outside user. So outside user is not actually seeing what's happening, how the email is getting calculated, or how the age or date of birth is getting handled. They are just accessing the attribute and they are getting what they want to see, and remaining everything is very properly shielded from the user. So this attribute, this property is also called as encapsulation. So encapsulation is a word you might be hearing a lot when you're learning about OOPS. So it's like one of the four pillars of OOPS. I have not discussed about those terms yet. We are still doing hands-on work. I'll take some time to explain all those words to you, but by the time we get there, you will already know what all of this is, even though if you don't know the terms. So let us continue with this example, and I think by the end of this example you will have a much better idea. So I'm going to write data validation in setter. Okay, so let me make it very clear what I'm trying to do. I'm trying to put some restriction when someone is assigning a name to a instance of this employee class. So let me take one example here and let me come back. Okay, we have this Rohan here, and if I do rohan.name, you see it is Rohan. And if I try to assign something to Rohan, okay, so maybe I want to put maybe something like this. Okay, so this also is getting accepted and there is no issue here, but I actually want to raise some error, or I want to tell the user that this is not a valid name, please enter a valid name. Whatever is the definition of valid, that is up to us. So for that I want to add name as a method instead of an attribute. So I will come here and I will say name. Okay, and I will take self here and I will make this name as a property. So what this name is going to do, it is going to return a temporary variable which will be name. So this is a convention of using a temporary variable or a private variable. This is not technically a private variable, this is a protected variable. I have not talked about private or protected. I think a video after this or a video before this, when I upload it, I will uh, I will upload about private and protected variables and name mangling also. But for now, just think of any attribute or any method that is starting with underscore is supposed to be private or is supposed to not be accessed outside of the class. And they come in two varieties. One is adding a single underscore, which is called as a protected variable, and you can add a double underscore, which makes it a private variable. Now, technically, they are not private, it is only a convention. It can be accessed, but it is more of a gentleman's agreement that if a method or an attribute has underscore or a double underscore before it, it should not be accessed. This can be completely accessed as it is. If I add a double underscore, it cannot be directly accessed, but there are ways to kind of bypass it. I'll show that to you right now. Just keep in mind that this is a temporary variable or a private variable for this use case. So I've created this name as a property, and this is my getter function. Fine. Now I want to come here and I want to write a setter function. So the function that will run when this statement is called. So when I'm trying to assign a name, self.name is equal to employee name, this line of code is going to trigger my setter function like I've shown you earlier. So again, I will do self and I'll come on top of here and I will say name dot setter. So this function is going to dictate what happens. This function is going to control what happens when we set a value to name. Okay, so here I'm going to write some docstring and I'm going to say only valid names will be set to name. So what is the definition of a valid name? Let me say valid name will not contain any numbers and will be less than 10 characters. You can have your own definition of what is valid, what is not. Okay, maybe you can have a logic where no special characters are allowed or whatever. So here I'm going to come and I'm going to check So actually setter will also take a value. Setter is also going to take a value, the value which we want to assign, and I'm going to check if name or is if value is alpha. So this alpha basically checks if there are any numbers or not. Basically, if it is consisting of alphabets or not. So if it is not alpha, then I'm going to maybe raise an exception. Okay, and else I'll say elif elif value or length of value. You can also do a type check, right? Value should be a string, it should not be an integer or something like that. So if length of value is greater than 10, then also I'm going to raise an exception, and I'm raising it separately because I might want to have different messages here. Let me say invalid name, and for the first case I will say name can't have numbers. Okay, and here I will say name must be less than 10 characters. So if these cases are not true and if exception is not raised, then I'm going to come here and I'm going to say self dot underscore name is equal to value. So this underscore name is like a placeholder or a private variable which will take the value. Okay, and when the getter is called, that is the value that will be returned. Okay, and this is the value that will be, this whole function will be run when when this statement is executed. And I can also add a deleter, but for now let me just run this, and in this case we will be able to use a deleter as well. So we'll do that, but first let me run this code and check whether it is working or not. So if I run this, you see it is working fine, but if I run this line, I'm not sure if this is alpha or not as per the Python function. Let me check. Okay, so this is not alpha. So if I run this, I should get some error. So you see I'm getting an exception and it says invalid name, name cannot contain numbers. So we have actually put a data validation, or we have put some kind of a check on the assignment of the name. So here if I come and if I just say Rahul, so this is going to work, right? But if I do Rohan dot name is equal to or let me check whether it was assigned or not. So if I come here and if I do this, it is working fine. If I do rohan.email, it's rahul@gmail.com. So email is also working fine. It is getting updated because email is also getting calculated dynamically. And if I do rohan.name is equal to maybe more than anything more than 10 characters. Okay, again I should get an error saying invalid name, name must be less than 10 characters. So if you know about custom exceptions, you can do that as well. But here I'm just using the raise command and I'm raising some exception. So this is like a data validation that I have put on name, and you can think of this also as backward compatibility. So let us take a moment to understand what backward compatibility actually means. It's an important concept because when you're writing code in production, often you will be asked if the changes that you are making are backward compatible. Okay. So backward compatibility basically means whatever changes you are making in your code or any changes that you are making in your existing system should not break anyone else's system who is dependent on you. So let me explain this using a very simple example. So suppose this is a phone that you're using. Okay, this is a phone, and this is running on some Android version or whatever operating system. Suppose this is using Android V1, and you're using a charger C1 to charge this phone. Now you get a notification that you have a new version of Android, and suppose this Android V1 is now getting converted to Android V2. And for some reason, when you update to Android V2, charger C1 does not work, and they're asking you to have a new charger C2, which means this update or the changes that the makers of Android made, that change is not backward compatible. So existing resources or existing hardware that you had has now become useless, and you have to update to a new hardware C2 charger uh, in order to use this new version of Android V2. So we will say that this is not backwards compatible. A backward compatible way would have been if Android V2 was designed in such a way that it supports C1 also and it supports C2 also, or there is no need for C2. Android V2 can work with the older charger that you had. So in that case, we will say Android, the new version of the operating system is backwards compatible, or it is supporting all the resources or data or code that was written for the earlier version. Okay. Let us also understand this in our existing code. So this was the earlier version of the code that I wrote before I added validation for name. So let me paste it here. And you see this is the class that we created. And let us say that this is our old code. Okay. And someone might be using this code to create employees like this and accessing the name. So this is what they expect. They expect to create an employee like this, and they expect to access the name of that employee using this rohan.name method. Now we want to make some changes in this old code. Okay, so we want to create a new version of this code. So let me now create a new version of this code, or add a new feature, or release an updated version of this code. So which might be this, where I am not allowing the user to access the name directly. Rather, I am creating a name property. So here the update that I wanted to add was that name is a feature that I don't want the user to access directly, which is also a good practice. I want to have some kind of validation. I already showed you an example of validation here. So let me take this getter and setter here, and this is what I wanted to add, right? So when I add this method, so I will say that the changes that I have made in this new implementation or the new feature are backward compatible only when they have been done in such a way that it does not break the code of anyone who was using the older version. So if someone was using the older version and he was accessing it like this, even after making the changes, he should be able to access it. You see here, they are still able to access even using the new implementation. And in the new implementation, I have added the feature, but it is not breaking the code that someone wrote previously. So then we will say that this code is backward compatible. So property decorator is allowing us to write backwards compatible code. We are able to add new feature, at the same time we are not breaking any syntax. So earlier they were accessing it directly using this name, and now they are accessing it using this property decorator, but in terms of syntax there is no change. When this would have been a non backwards compatible code, when instead of doing this, I would have done maybe something like created a new method, okay, get name, okay, and here I was returning for some reason self dot name. So if I created a new method here, and then I'm asking everyone to not use this name but rather use rohan dot get name, so then it is very frustrating for that person, because he has to go in his code and change this name to get name everywhere. And if you are having hundreds of implementations and hundreds of users, this is going to be error prone, and this is going to cause a lot of problem. So for this reason, writing backwards compatible code is very, very important. So let us come back to the example that we were discussing, and let us see what more we can do here now that we have discussed about backward compatibility. So we converted this name from an attribute to a method. We added this property decorator, and we wrote a getter and a setter function here. We did not write a deleter function, so let me do that. Earlier I showed you this deleter function, but this was just a dummy function for email. So email was getting dynamically calculated, so there was no sense of adding deleter. But for name, we can definitely add a deleter here. So let me write this name method again, and this is going to take self. And here I'm going to add at the rate name dot deleter. So there is a setter function. Now I'm adding a deleter function. So this deleter function will print deleting the name. Okay. And let me run this. And now if I come here and if I do rohan dot name, let me do rohan dot name. It says name, and if I write this del command and then I do rohan dot name, you see it says deleting the name. But if I try to access rohan dot name, I'm able to get this back because I've not actually done anything here. I'm just printing. So here I can come and I can set self dot underscore name is equal to none. Now why I'm doing underscore name? Because this is the temporary variable, or this is the protected variable that this name parameter is returning. So when we are getting name, actually this attribute is being returned, which is protected. And this is not directly exposed to the outside user, at least not in the sense of convention. So that is what I'm setting to none here. And now if I run this and I create this class, and if I add rohan.name and then I do this deleting, and now if I try to access rohan.name, you see I will not get anything because rohan.name has now been deleted. And if I compare it to none, you see it is actually none, it is giving me true. Now again, if I want to set name for rohan, I can do rohan.name is equal to something, and then this setter command will run. This setter method is going to run, and it will assign some value to this name, but only after a validation check has been done. So let me come back here and do rohan.name, and let me add some name here. So I'm going to put Rohan Kumar. I don't think I will be allowed to put this space here because I'm checking for alphabet. I'm checking if all the characters are alphabets. So this might give me an error. Let me just try this. You see, I'm getting an error for invalid name. Name cannot contain numbers. And this does not have a number, but this space is also being considered as a non-alphabetical character. So I can come and remove the space here. And again, if I now try to access the name and email, see, I'm getting the name and I'm getting the email. So this is how you can also add a deleter function. Deleter function only makes sense when you're storing something in an attribute. So here name attribute is storing the name. Okay, so that's why it makes sense. So this is all about backward compatibility and adding data validation and using the deleter function. I think I've discussed a lot of things here. So now let us go back to the agenda that we had set towards the beginning of the video and see how much ground we have covered. So let me come back here and let us do a revisit of everything that we started with. So you see now it says the property decorator is a built-in decorator, right? So we discussed about the built-in decorator, and there are built-in decorators and there are custom decorators. So custom decorators probably we'll discuss in some other video. But in terms of built-in decorators, you now know three different types of built-in decorators, right? You know class method, we discussed that in the last video, and you know static method, and now you also know property method or property decorator. So these are the three built-in decorators that we are using. There are other built-in decorators also, but these three are what we have seen so far in terms of object-oriented programming. And then the definition says that it is allowing us to define methods that can be accessed like attributes. So this should make complete sense now, because this is what we have been discussing so far. And next it says that it is enabling controlled access to instance variables. Again, this should now make sense, because we saw how we can control the access to the instance variables using the getter and the setter, and we also added some data validation. So we are not allowing the user to directly access an instance variable, we are controlling it in some way. Nobody is directly calling the name. When they call the name, we are controlling what happens. Maybe we want to modify it in certain way, or we want to add some kind of a check, maybe we want to add some kind of authentication. So the internal working of how my class is behaving, the internal working of my class is kind of hidden from the user, and we are only exposing what the user has to do. Okay, internal working is hidden. It is just like operating any kind of machine or a phone, right? When you press the on button on a remote, the AC switches on. Now what exactly happens behind the scenes is actually hidden from us, or it is encapsulated. So this idea is only called as encapsulation. So we'll discuss that in a little bit of detail, but by the virtue of everything that we have discussed, you already know what is encapsulation. Encapsulation is also one of the four pillars of OOPS, as it is mentioned in a lot of literature. Encapsulation, polymorphism. So the way I am discussing, I'm already you the with the examples that we have done, you already know what is encapsulation. Okay, just that the definition is now being exposed to you. So we are enabling the controlled access to instance variable, and it is a part of Python's property mechanism, which helps us in getting getters, setters, and deleters. So these three are also very clear to you now. So the next thing is why we should use property decorator, or what is the use case. Again, this I've discussed earlier, but now that we have had so much discussion, this should make a little bit more sense to you. So readability of the code, of course, the property decorator is making the code more readable. Instead of adding some methods like get age or get name, we are accessing those attributes just like how it is supposed to be accessed, like an attribute. So we are using ramesh.name. We are not saying ramesh.getName. So it is allowing us to maintain the syntax. It is allowing us to maintain the convention, or it is making the code more readable. And the next point is encapsulation. So encapsulation again is an overarching idea. It oversees everything that we have discussed so far. Like I said, it is basically hiding away the internal workings of my class from the user, and enabling a system where the user is interacting with my class in a way that I want him to. So for example, if the user wants to set a variable, I can have some data validation, I can have some kind of authentication, I can maybe not allow a certain variable to be changed. If I just write the getter function, if I don't write the setter function, then the user will not be able to set the value. I give you an example of how we can add data validation to the name. Similarly, you can also add data validation to maybe age, right? And then we discussed about computed attributes, dynamically computing certain attribute values like email, right? I give you that example. So we also talked about backward compatibility. Now backward compatibility, like I said, we are modifying the logic, internal logic, but the external user is not going to see the impact of that change in terms of the syntax. So he's also going to use the same syntax that he was using earlier, but the internal logic has been modified. And then comes two more topics that I have not discussed so far, which is lazy computation and caching. So these are the two things we will discuss. This is not anything new. This also comes under the earlier points like computed attributes or backward compatibility or validation. This is not anything new, but in terms of use, this has kind of a niche use. So I've kept it as a different point. Now I'll discuss lazy computation first. I will give you one example, and then I will give you one example of caching. Okay. So lazy computation is just like the name says, it is being lazy, not doing the work unless you are actually needed to do the work. So lazy computation is trying to defer or trying to avoid anything that is expensive. We will do that task only when we are forced to do it, or we will do it only when the user is explicitly asking for it. Now, when I say expensive, expensive in computer science only means two things. Either it is expensive by time, which means it takes a lot of time, or it takes a lot of resources, or it takes a lot of CPU power, or both. It takes a lot of CPU power and it takes a lot of time. That virtue of an operation is called as an expensive operation or expensive computation. So when we are dealing with such kind of expensive computations, we need to handle them intelligently for obvious reasons, because they are going to cost us money or time, right? So how do we handle these expensive computations using lazy computation is something that we will see now. Now, lazy computation you will also come across when you are learning certain machine learning algorithms, where a machine learning algorithm does not do the heavy lifting task unless it is absolutely needed. So let us try to understand what I mean when I say lazy computation as an application of the property decorator. Okay. So like I said, lazy computation is a subset of something we have already discussed, which is dynamically computing a value. We saw this when we were trying to work with the email characteristic, where we were not assigning the email at the time of object creation, but rather we were dynamically calculating it. Now, email is not a very expensive process, but we will see how to take that idea and implement it when we are dealing with something that is expensive. So I am going to create a class called data processor. Now, this is an abstraction. This is a class that will kind of dictate what happens when we are trying to process some data. I'm going to take a mock here. So I'm writing an init function which will take self and which will take source, the source from where we are going to get the data. And I'm going to assign source here. So this source can be some kind of storage where we have stored a lot of files which we want to read, or it can be a table in some database. It doesn't matter. And then we have data. Okay, so data is what we are trying to get, and here I'm just saying none, and let me create a function to fetch the data. Okay, so this data will take self, and then I'm just going to print here that fetching the data and fetching the data. So just as a dummy, let me try to return the square sum of squares of all the numbers from 1 to 1000. So how can I do that? Let me come here and I square of I for I in range maybe 10,000. So this is going to return me sum of all the squares, sum of the square of all the numbers from 1 to 10,000. I'm here, let me use the function sum. Okay, this is just a dummy. Here actually you will have a lot of logic of reading heavy files, which is going to take some time. And in order to simulate that time which is being taken, so let me use the time module here, and let me just do a time dot sleep of 5 seconds. So this code is just going to make the code sleep for 5 seconds. Nothing will happen for 5 seconds, just to simulate an environment where an operation is taking some time. And if I'm not using any property decorator, what I will do is I will use this self.data, and I will just assign here the result from this fetch data. So this code is going to run at the time of initialization. This is not lazy computation, this is normal computation. So I'm going to create this class, and here I will call processor will be my data processor. And here I will give source as some dummy source. Maybe I'm just writing dummy database. So I've given the source here as some a dummy database. Okay. So if I run this code now, you see I have created this thing, and it is fetching the data at the time of creation of this processor. And this is not lazy computation. Maybe we don't even need this data because we have not yet accessed the data. But still it is running this code and trying to fetch the data. Now how can I modify this code using property decorator? So I can come here and I can say self.data. So I can remove this and I can come here and I can create data as a method with the property decorator. So this is now going to allow me to use data as a attribute. And here I'm going to come and say return self dot fetch data. Okay. So the person who was using here, if he comes here and does processor dot data, you see he's able to get the result. And now I'm making some change here. And instead of having data as a eager loading, this is also called as eager processing, eager because it is very eager to get the data even when it is not needed. It is eagerly fetching the data, so that's why it is called as eager processing. So I'm removing this eager processing from here, and I'm adding a property to fetch the data. So now what happens when I run this code, you see it is immediately running. If I run the same code, and again you see this code is backward compatible, the way the person is using my class is not going to change. So I'm using this processor now, and you see it did not take any time. Whereas when I was running here, it started fetching the data at the time of creation of this class. Now, when the user is explicitly asking for data, Okay, when I'm using this dot data notation, when I actually need the data, at that point of time it is fetching the data, right? So this is called as lazy computation or lazy execution, where the expensive process is done when the user is demanding it or when there is actual requirement for it. Until such time comes, this method will not be executed, and this is something we can accomplish using this property decorator. Okay, and this is also called as dynamically computing the value. You can also take this as an example of dynamically computing the value, just like the email example I gave earlier. Okay, an extension of the same idea, but this will find some use case when you're trying to work on some heavy data sets where you don't want to unnecessary do the expensive process while it is not needed. You don't want to do that task eagerly. So this is a simple example I wanted to show you about lazy computation. And the last topic that I want to show you is another example, is which is caching. Now caching again is very similar to what I've shown you earlier, but let us try to understand this using an example, and this is also something that will come in very handy. So first let us understand what caching actually means. So cache is a word you might have heard quite often. Caching is a very common technique that is used to save time and resource when we are doing certain operations. So if you go to the history of your browser and you try to clear the history, you will often have an option of clear cache. Okay, so that cache is the same concept that we are talking about. Cache basically means when we are doing an operation again and again. Suppose we are trying to fetch a particular data from a database again and again multiple times. So instead of doing that multiple times, you do it once and you save it, so that the next time the user is asking for it, you can quickly provide it to the user. For example, when I'm trying to load a website, when we are loading a website, there is so much of information that is coming to us. For example, all the icons and all the graphics, etc. Now when we are trying to reload the page again and again, there is no sense of again and again loading everything. So what the browser does is it calls the website once, and it stores all the information locally, so that the next time we call the website, it does not have to go and actually call the server. All the information, most of the information is available locally. That is called as a cache. And it is a very important concept, because when a user is requesting for some data from a database, or you are trying to call a function that is supposed to give you some answer, and you are calling that function again and again, or you are making a query to the database again and again, or you are making a call to the server again and again, and if it is every time returning the same answer, it is better to avoid that situation and store it once somewhere, so that the next time there is a requirement, we can, instead of calling the expensive API to the server or to the database, we are relying on the locally stored version of the same data. That locally stored version of the data is called as cache. So caching is also something that we can implement using the property decorator. So for caching, let me show you a quick example. So let me take example of a document. Okay, so this document I'm imagining like a Word document or a Google Doc that you might be using, or you can imagine this like a text file. Okay, so I'm creating a init method. So this document, what we are going to do, we are going to allow the user to add some text. Okay, we are going to allow the user to read the text, and I'm also going to allow the user to find out the number of characters or number of words in the text. Okay, so this is the idea. We will have a document, a file, and we will allow the user to add the text, read the text, and find out the number of words in the text. Every time a user is trying to find out the number of words in the text, we need to go and calculate this thing, right? So if the user is asking for this again and again, we should not call the function to calculate the number of words in the text again and again. So we'll do it once and we will store it. When we are adding the text, then the length of the text or the number of words is going to change. Only in that situation, we will delete the cache. Okay, and we will calculate it again. But if we have not added any text, then the number of words in the text is going to remain same. In such a situation, if the user is asking for number of words again and again, or multiple users are doing that, then we don't want to call this function for calculating the number of words in the text again and again. Okay, so I hope you understand what is the use and where caching is coming into picture, and now we are going to implement this using this class document. Okay, so I'm going to init this, and while we can add some starting text. Okay, so what we will do is I'm going to do self dot text is equal to text. So instead of doing self dot text here, I want to do self dot underscore text is equal to text. What happens here is, so if I do this, this variable underscore text, this becomes a protected attribute. Now adding underscore is an indication to anyone to not to not try to access this outside of the class. So you might ask, then how will the user read the text? Because in order to read the text, they will need to use this attribute. So I'm going to control that. Like I have explained to you in the case of encapsulation, we are going to control how the user is going to get and set the text. So I will not allow the user to directly use this. I will probably create a method. I can create a method called get text. Okay, and self, and here I can just return self dot underscore text. So user will not be able to directly use text. He has to use it via this method, get text method. And maybe I can print something here. I can say print reading the text now. Okay, so I'm controlling it. You can do it this way, or we know about property decorators, so we can also maintain the syntax of dot text. At the same time, we can also control how the user is going to access it. So I can do text and I can convert this to a property. Both of these are valid, but because we are learning about property, so I'm going to use property and I'm going to say self, and I'm going to not do anything here, and I'm just going to return uh, self dot underscore text. So far so good, but now we want to add, we also want to allow the user to add some text. Okay, so I'm going to say def text, and I'm going to say self. Okay, and I'm going to say this is going to be text dot setter, and I'm going to say self dot underscore text is equal to self dot underscore text plus, and this setter will also take a value, so this will take plus value. Let me also add a new line, so when we are trying to add the text, it will go in a new line. Okay, so you can also do this, or you can also just avoid this part and just reset everything. So it's up to you how you want to do it. Okay, and then I'm going to come, and here I'm going to write a function to calculate length, or calculate the word count. Okay, or maybe I can just have word count as a, this also will be a property. So let me write this property. Now this word count is supposed to be, we are assuming that this is going to be an expensive operation, word count, and then here I'm going to pass self again. So this is going to calculate how many words are there. So I'm going to calculate number of words. Number of words is going to be self dot underscore text, and I'm going to split it in order to get the number of words, and then let me take the length. Okay, and for now we are just pretending that this is going to be a very time taking operation, and we want to avoid this kind of task. And I'm going to return, and I'm going to return this number of words. Okay, so if we do this, this is fine, and let me just print here calculating the number of words. So let me come here and let me create some documents and try to explain to you what is happening here. I have not implemented any caching here. We'll do that in a while. So I'll say document doc1 is equal to document, and I want to initialize it with some text. Hello, how are you? So this is the text that I'm having in the document. So if I come back, if I come here and if I run this, and then if I do doc dot text, you see, sorry, here I made a typo. It should be dot underscore text. If I come here and you see, we are able to read the text. Now if I want to find the word count, I should be able to do it like this, and it is giving me calculating number of words, which is 4. Now if I run this again, you see again it is calculating the number of words. Maybe I can add a time dot sleep of 1 second for you to kind of imagine that it is taking some time. So if you see here, again it is taking 1 second and it is calculating. And if I have not made any change, and if I'm running the code again, it is again calculating the number of words. So this is a waste operation. It should not be done because the number of words are not changing. So if I'm calling this function again and again, why should it calculate the words? Why should it call this function multiple number of times? It is just a waste of time. So we should design it in a slightly better way. So what we can do is we can come here and we can add a cache. We can say underscore word count cache, and we can set it to none. So initially it is none, and once we have calculated that, once we have calculated the number of words, we are going to set this in the cache. We are going to say self dot word count cache is equal to number of words. Now this calculation should happen, only if word count cache does not have any value. So I will say if self dot word count self dot underscore word count cache is none. In case it is none, then only I should do this expensive operation. If this is not the case, and word count cache is already having, it is already containing the number of words, then I'm just going to return the number of words. Now this might seem a little bit tricky, so take some time to understand what I'm doing. I'm keeping this variable here as none, and the first time when I'm trying to calculate the number of words, this condition is going to be true because it is none. So I'm going to come down here and I'm going to calculate the number of words, and I'm going to set it to that variable number of words. So it is now saved, just like the local storage example I gave you. So this is kind of a local storage. I've stored it and I'm going to return it. No problem. Okay, I should return this value here and I'm going to return it. The next time you call the function, already word count cache has the value of 4. So if it has the value of 4, then this code will not run and we will return directly 4 from here. That is what is happening. So if I come here and if I run this code again, you see if I do the word count, it will take some time. It will say calculating the number of words 4. But if I run it again, it will not do that. It will directly give me 4, which means this block of code was not run. So it is much faster now. I hope you understood what is the meaning of cache and how we have implemented this here. Now it is not necessary that caching will be implemented only using the property decorator. It can be done otherwise also, but it is more efficient and you don't have to use any other syntax for doing word count. I'm doing word count, but if you don't use the property decorator, you will have to convert this to a method, which might not be acceptable. Now there is only one case where we are adding some text here. Say for example, now if I'm doing doc dot text is equal to, I'm adding some more things. I'm just doing hello. Okay, so if I do hello here and again if I go and do word count, you see it will give me 4. Text is only one letter long, but this is giving me 4 because we are not resetting the count cache to none after we have set the value. So if we are changing the word count, in that case we need to come and we need to set this to none. Let me write the reason here. Because we have changed the text, the actual data has changed, so the whatever we have stored locally is not having any meaning now. So we need to reset it to none, so that when we call the word count again, this method will be called. So we have changed the text, so cache should be cleared. So now if you come here and if you see, I'm doing hello, how are you, and I'm doing word count, it will take some time to process it. It is saying calculating number of words and then it is giving me the answer. And if I do it again, you see it will not do the processing, it will directly give me the result. But if I'm changing the text from 4 to 1, okay, or I can say hello, I am coming from Bangalore to Hyderabad. So if I'm giving this example, now if I do word dot count, again it will process. It is calculating number of words, which is 12. 1, 2, 3, 4, 5, 6. Why is it 12? Okay, it is giving me 12 because actually I'm adding it to the previous text here. So which makes sense, because if we look for doc.text, it is actually adding to the last text. If we print it, so it is adding to the previous one. So I think I can remove it here and I cannot add it. If I do this now, you see it is calculating the number of words 4. If I come here, it is saying 4. And if I run this again, it will not calculate. And now I am updating it to a different value, which is having 1, 2, 3, 4, 5, 6, 7, 8 words. So this should give me doc.text. Sorry, here again there's a mistake. I should add value here. Sorry, so many bugs. So again, if we come back here, the text is giving, the text here is coming as hello, I'm coming from Bangalore to Hyderabad. And if I do a word count, it will give me answer 8. But if I run it again, it will not do the calculation and it is giving me the direct word 8. So this is the example of caching. I hope you understood what I meant. I hope you got a good idea of what is the property decorator, where it is going to be used, why we are using it, and what are the different getters and setters and deleters, and what is the point of it. Now, usually, if you learn about property decorator, normally people will just show you what is, how do we convert a method to an attribute. But actually, this goes a long way, and a lot of things that we have done here, this is also a general knowledge for you as a developer, and for that reason, this video is also quite long. So guys, this brings us to the end of the video. If you have stuck around till the end of this long video on property decorators, then I can assure you that you have a well-rounded knowledge of how to use object-oriented programming and different methods and the property decorator, and you have a more solidified understanding of what are methods and attributes. And through this video and through the examples, I also try to cover some general topics like backward compatibility or data validation, right? Caching, lazy computation. So these are the topics that you should be familiar with and you should know as a Python developer or as a software developer, or in fact as a data engineer, data scientist, machine learning engineer. Now it is not possible to make separate videos for all of this, but through this video you got some exposure to what these things mean, and you were able to imagine where all of these things can come into picture when you are working on an industry use case. So with that being said, if you have any questions, if you have any doubts, please put them down in the comment section below. You can also connect with me on Discord if you have any suggestions. I'll try to tend to them personally. And if you're new to this channel, this video is a part of my Hands on Python for Beginners playlist. So if you're someone who's just starting out your Python journey, this playlist might be for you. The link for the playlist is in the description below. Check it out, and I'll see you in the next video. Thank you.